Hey guys, it's Miss Johnson here, and I'm here to bring you notes today on factoring. We're going to start off with a little Halloween joke. What do you get if you divide the circumference of a jack-o'-lantern by its diameter? Dun, 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 pumpkin pie! Ha ha ha. So, we're going to be talking about factoring today, doing some reviewing. We've done a lot of factoring in the past. You did a lot of factoring in Algebra 1, but we're just taking a little time to come back to it and refresh our memories on it before we get going further into this quadratics unit. So, the first thing, what is factoring? Factoring is the act of taking apart a number or an expression that's written as a product of its factors. So basically, what we're doing when we are factoring is we are undoing the multiplication. And one way that we could look at that, or one example of that, could be 20 is the same thing as 2 times 2 times 5. That's the prime factorization of 20. Or 15a squared b to the third is 3 times 5 times a times a times b times b times b. Again, prime factorization of that is undoing the multiplication, taking it back apart. So we're going to start off with a few factor puzzles here. What we want to look for in these factor puzzles is what are the common factors that we can take out of each pair of numbers. So if I look at each row and each column, I want to find the common factor that I can take out of them. And that's going to lead me to the missing product that's on the inside. So in the top row here, I have 12 and 15. The common factor that can come out of that is 3. In the first column here, 12 and 8, the common factor that can come out of that is 4. And then what I want to ask myself to get these other numbers is what times 4 gives me 8, because 8 is the product. 4 is one of the factors. What's the other factor that I need? Well, 4 times 2 gives me 8. That means there needs to be a 2 over here. And what number times 3 gives me 15? Well, that would be 5, which means there needs to be a 5 down here. So then the missing product in the middle, 5 times 2 is 10. Let's try another one. In number 2, if I look at the first column, 8 and 14 have a common factor of 2. If I look at the bottom row, 14 and 21 have a common factor of 7. So I'm pulling out the GCF, pulling out the common factor. So then I ask myself, what number times 2 gives me 8? And that's a 4. So that means there has to be a 4 over here. And what number times 7 gives me 21? That's 3. So that means there needs to be a 3 up here. So the missing product on the inside is 12. In number 3, we have 8 and 12 in the first row. That common factor would be 4, the GCF. And 12 and 15, the common factor would be 3. So then what number times 4 gives me 8? That's a 2. What number times 3 gives me 12? Oh, that's the 4 from over there. That's the 3. What number times 3 gives me 15? That's a 5. So that means there's a 5 over there. This one's a 2, so that's a 2. And again, we're in the 10. So if you notice 1 and 3, 1 and 3, the numbers were listed in different orders, but the factors turned out to be the same, giving us the same missing product. So even though they're in a different order, our factors are still the same. I want you guys to go ahead and pause the video and see if you can work on the next 3 factor puzzles. Take care of those 3 factor puzzles there in numbers 4, 5, and 6. So let's just talk about the different types of factoring that we have. Factoring is simply the opposite of FOILing, or the opposite of distributing, or in other words, the opposite of multiplying. We are taking apart whatever we had multiplied. So when factored, answers will look similar to the original problems. The original problems being, um, the factors all list out this times this times this times this. So there's a bunch of different types of factoring. One type of factoring is GCF. That's where we take out or divide out the greatest common factor. And that's kind of what we were doing in the factor puzzles. We were just looking for the GCF and dividing it out of both parts. Then we have trinomials. Trinomials have 3 terms. That's why they're called trinomials. And when they have a 1 in front of the x squared, that means that we're going to end up with some sort of binomial where we have x and we're adding, oops, adding, not multiplying. We're going to be adding numbers that give us a product of C and a sum of B. So whatever numbers give us a product of B and a sum of C, that's what we're going to put there and there. So two binomials there. Then when we get into trinomials that have a number in front, now we have an A, something other than 1. That's when we have to do a little bit more work. Numbers other than 1. We're still going to end up with some sort of binomial, but we might have some number in front of the x plus whatever. Some number in front of the x plus whatever. And it just depends on what these numbers are. But when we get into that type of factoring, when there's a number other than 1 in front of the x, we have to use what's called grouping. And when we have grouping, this is when you have 4 terms. Okay, you group the first 2 and you group the last 2. And then you take the GCF out of each part. And you get your factors that way. Okay. So we're going to look at all those types of factoring today. Let's just start by looking at a few GCFs here. All right, so if I look at number 7, I want to pull the GCF out of 12x minus 36, so I need to look at what's in common between both of those. Now, I could take out a 2. Both numbers are divisible by 2. I could probably even take out a 4. Both numbers are divisible by 4. But I want the greatest common factor. So the greatest common factor between 12x and 36 is going to be 6. So I can take a 6 out of those. Actually, no. I'm even lying. 6 is another factor. That's not the greatest one. The greatest one is actually 12. I can take out a 12 from both of those. And essentially what that means is you're dividing by 12. That leaves me with x minus 3 behind it. So that's its factored form. 12 is one factor. X minus 3 altogether is another factor. From 8x squared plus 16x, I can take out an 8. And now I can take out an x from both parts. So I have 8x out front. 8x squared divided by 8x leaves me with 1x left over, and 16x divided by 8x leaves me with 2. So again, 8x is one of my factors, and x plus 2 is a whole nother factor. If I look at 39x squared plus 13x, I can take out a 13. I can also take out an x, so I have 13x. Then when I divide 39x squared by 13x, I get 3x left over. 13x divided by 13x is 1, and yes, I need to write it plus 1. If I dropped off that plus 1, then I'd lose that whole term when I put the multiplication back together. So here's one of my factors. There's the other one. And this last one, now I have 3 terms to pull a GCF out of. It looks like all 3 numbers or coefficients are divisible by 5, so I can take a 5 out front. Then I want to look at the x's as well. I have x to the 7th, x to the 3rd, and x squared. Well, I can only take out the largest number that every term has, so I can take out x squared. So then when I divide 5x to the 7th by 5x squared, I'm left with x to the 5th left over. 20x to the 3rd divided by 5x squared is minus 4x. I took away 2 x's. 20 divided by 5 is 4. And 40 divided by 5 gives me 8. X squared divided by x squared is just gone. So this is one factor. This is another factor. All right, we're going to go ahead and stop the video at this point. Thanks for listening, and we'll finish up our factoring practice tomorrow. Don't forget to hop back to Schoology and take your quiz.